So let's talk about how we're going to read delimited text files. We're going to eventually here be using the CSV module to do this. Now that's a standard module. It should be already installed for you. If you want to check, I can just start up Python. I can say import CSV, and that doesn't blow up, so that means it was fine. So there's nothing to install here. This is a standard module. There are a couple of other modules though that we want to use that are most likely not installed on your program on your system. One's called CSV Kit. We're not really going to use it for programming the exercise, but it's a really fantastic module, and I think you should be aware of it. And then we are going to use the Tabulate module. So I can take this command and I can run it over here to install these modules. Looks like I haven't installed CSV Kit yet. Now I got a new machine. So this is what it looks like when we ask pip to install that. And then it also installed the Tabulate module. I'd like to point out there's also a requirements.txt file. It's very common when you are installing a piece of code from someone, or maybe if you're creating something for other people to install, that you'll create this requirements.txt file, and you'll just list all of the non-standard modules that your user is going to need to install. We've done it with the barest of syntax here. I've listed each module on a separate line, but you can additionally require certain versions of the modules. I usually just try to use the latest versions of all the modules and just hope that everything works out. It depends on how serious you want to get about, maybe even creating virtual environments, well beyond the scope of what we want to talk about here. But this is one other way to document all the requirements for a project, and then it's possible to install with pip using the -r requirements.txt, and then it will just install all of the modules that are listed in this file. So a couple different ways to install that. I wanted to install that so that I could use this program called CSV Look. So if I have that installed now, I can say CSV Look, and I'm going to use this max rows option here of 3, and I'm going to look at inputs exercises.csv. And if I do that, I see the same output as what is shown in the book here. CSV Look is one of the programs that's installed by CSV Kit. If you type CSV and then hit tab, you'll see a lot of other programs, some of which I'm not sure if all of these come from that module. They may, I can't remember, but lots of different modules that you can use to programs that you can use to look and sort and kind of work with CSV files. You may be used to perhaps opening CSV files in Excel, and that's really useful as long as the file isn't too large or maybe doesn't have too many columns. Excel has a limit of the number of rows that it can handle, and I regularly deal with data files that have hundreds of thousands to even millions of rows. Nothing that I could do anything with Excel. I really have to work with these files programmatically. So how are we going to read this? So we're going to need to open this file inside of our program, and then we're going to have to take out this reps column, and then we're going to have to convert those to the numbers 20 and 50, and then we're going to use this randint function to select an integer. And we want to be able to randomly select some exercises, so that we want to do it in such a way that it's repeatable using a seed. And when it's easy, we're going to cut those numbers in half, so 32 becomes 16 and on. And we want to be able to read a couple of different, more than one input file. We want that file to be determined on the command line. So this is what it's going to look like, the arguments to our program, and then what's going to come out is this table that tells us what to do. So let's talk about how to manually read this input file. And we'll just go ahead and stick with the inputs exercises.csv, and then the other there's another file that we'll alternately use that has the same structure, and then we're going to talk about files that have slightly different structure or messed up data, and see how that affects our program. There's a manual1.py here, and if I run this program, let's see what it looks like. So it shows this output that we see in the book. And so we can look at how this program works. Let's just open that up. Let's see, where is manual 1, PY? So it's using this with open syntax that we almost never have to write in the programs for this book, because we're usually accepting files as parameters. And then we're asking argparse to validate them and open them for us so that we already have an open file handle. But this is a very common Python construct with open as file handle here. What we're doing here is we're reading the first line from the file, which is this line. And if we go back here and we do head-3 on inputs exercises, the first line is exercises reps. So we're reading that with read line, reading one line. We're stripping off any white space, and then we're splitting that line on commas, and that gives us our headers. And then we're creating this empty list to hold our records, and then we're going to go through the rest of the lines after the first line. And here I'm showing a really nifty little trick here with using the zip function to combine the headers with the same operation of taking each line that follows, stripping it and splitting it on commas, and zipping those together and turning that into a dictionary in order to create this structure here. And that's what I'm showing here in the annotations here. Let's think for a second about what's going on here with the headers. If we split those, we're going to get exercise reps. We're going to get a list of 2 values. And then if we take the next line, and if we look at that next line as burpees, comma 2050. If we do that option, this code on that line, then we're going to get a new list with burpees, comma 2050. And if we want to zip the headers with the line such that it creates this structure where exercise's name, exercise is the key, burpees is the value. The key here is reps and 2050 is the value. And we're doing that for each one of the rows in our file so that we get this list of dictionaries. So looking at this closely, the outer square brackets tell us this is a list, and then these inner square curly brackets tell us this is the dictionary. So a list of dictionaries. Each dictionary has the same structure with exercise and reps. So we're using the zip function to combine the headers and each line into a new dictionary. And I have this idea to try to help you understand what zipping does. Imagine, you're at a wedding, the bride and groom, they get pronounced man and wife, they kiss, and then they turn and walk down the aisle. And then you're left with 3 groomsmen on one side and 3 bridesmaids on the others. And in order for them to leave, usually there's an even number, and each groomsman and bridesmaid who are closest to each other will come together. Often the bridesmaid will hook her arm into the groomsman's, her hand into the groomsman's arms, and then they'll walk down the aisle as a pair. And it's very awkward if there's not the same number of groomsmen and bridesmaids. So you generally want to balance those. But if they are balanced, then we can get a pair, each 3 pairs. So if there originally were 3 on each side, we're going to end up with 3 pairs, groomsman, bridesmaid, groomsman, bridesmaid, on like that. So that's, another way to think of it would be you're trying to get out of a parking lot, and you have 2 lines of cars that are coming together. They're going to zip together. It, usually, in polite society, it's not going to be that everyone from one side gets to go and then everyone from the other side gets to go. Usually we alternate 1 car from one lane, 1 car from the other lane, and we zip it together like a zipper, like the teeth of a zipper. And so the result is, a line, a car from column A, a car from column B, and then A, B, and they alternate like that. So that's what zip is kind of trying to make you think about, like zipping these lists together. So if I zip ABC 1, 2, 3, there are going to be, just like with the groomsmen and bridesmaids, 3 pair. A1 gets paired together, B2 together, C3 together. And so what happens if, like with the bridesmaids and groomsmen, there's not an even number. Well, in real life, somebody would have to walk down the aisle alone, or maybe they'll walk down with the flower girl or something like that, because you want it to look balanced. But in the normal operation of zipping, it will just zip to the shortest list here. So even though A, B, C, D, 1, 2, 3, 4 have 4 elements, X, Y, Z only has 3. So normally zip will zip to the shortest list there is. And so what we're seeing here is that you can zip any number of lists together to create a new list with where each member is a tuple that contains one element from each of the other lists, but only down to the shortest one, which is why this one ends with C3Z. So when we have our headers and our line of data, and we zip those together, we're going to end up with a list of 2 tuples, and those tuples are going to have 2 values each. If you see this, a list of tuples, 2 tuples together, hopefully that immediately makes you think of a dictionary, because if you ask for the items in a dictionary, this is exactly the data structure you'll get, a list of tuples. So if you have a list of 2 tuples, you can use the dict function to turn those into a dictionary, where in this tuple, this becomes the key and that becomes the value. This becomes the key and that becomes the value. And so it's a really short way to create a dictionary from 2 lists. Really, really handy, and I use this trick all the time. So there is a shorter way to write all this, of course, as a dictionary, as a list comprehension. And inside, so we're just taking that 4 line in the file handle after we get our headers, and we're taking, sorry, that's my dog, he's unhappy about something. And we zip the headers here with each line, and we're just taking the code that we already saw, and then that creates a list of dictionaries. It's exactly the same result as before. One other way to write that, which is I always think it's fun to write things with using a map statement, is I create a function called makeRecord, and that makeRecord is going to take the next line of input and call this code on it. And so it's going to take each line, zip it with the headers, and turn that into a dictionary. So if I map the rest of the file handle, the lines in the file handle, after I've taken the headers out, if I map the rest of those lines through makeRecord, I'm going to also end up with a list of dictionaries. So it's a lot of code to show you. First off, the zip function, which is just really awesome. Also how you can use the dict function to turn a list of 2 tuples into a dictionary, which is really, really handy. But hopefully now you truly understand what the CSV module is going to be doing for us, because the next thing I'm going to show you is how to not do any of this. And we'll let the CSV module handle it for us.